continue with the power of e, which is the derivative of ln of x and e to the x power. So let's get it started. So first, we want to write the derivative as a limit function with the definition of the derivative, which is equal to the limit as h approaches to 0 of ln of x plus h minus ln of x, and entire thing divided by what? Divided by h. So now, how are we going to proceed? Now we can actually simplify the numerator a little bit. Okay, I spelled it wrong. Which is just equal to ln of x plus 1 plus h over x and then divide by h. Right, so how does this give us some insight on how to prove it? So then we're going to write it as the limit as h approaches to 0 of 1 over ln of 1 plus h over x to the 1 over h's power. So let me explain what did I do here. So basically, I just uses the property of logarithmics to simplify into an exponential equation and a log. So now how are we going to proceed? Let me just make this parentheses a little bit larger. So now, how are we going to proceed? So we can see that the inside part is actually quite look similar as e, because e can be written as in one of ways as ln the limit as x approaches to 0 of one plus x to the 1 over x power. So this is one of the properties of e. So now how are we going to utilize this to make our life a little bit easier? Well, some insight would be let m be equal to h over x. Then the derivative can be expressed as the limit. Oh, holy! It's really like annoying, tedious to write limit over and over again. I should just copy and paste it, honestly. So ln of 1 plus n to the so I can write it in this form. So what did I do is I just basically substituted in n equals to h over x. Then I can write it as limit as h approaches to 0 of ln of 1 plus n to the 1 of n times 1 over x, which we can actually just take the constant outside, and we can also take ln in front of limit. Ln of the limit as h approaches to 0, ln 1 plus n the limit as h approaches to 0 of ln of 1 plus n to the 1 over n, which is just equal to 1 over x times 1, which is just equal to so this is how the derivative of ln of x is being evaluated. So now let's continue with our next topic. So for e of x, this thing you have to do is you can basically just plug in values, right? So now let's see the insight. The insight of sine of x and e to the x derivative. So after you just plug in values, then you can see that the derivative of e to the x power, it's basically just e to the x power itself. So now let's continue with our next topic. So what insight can we have with the derivative of ln of x? So we don't have to just plug in values. So we don't have to just like rewrite it as the definition of the derivative every time. Something really interesting is we can first let y equals to f of x. So this is the first step. And then we can take the natural log of both sides. And then we can take the derivative of both sides with respect to x. You can see that dy over dx of ln of y is equal to something like, well, 1 over f of x f prime of x. So then you want to find d over dy, and you just take the derivative in the left. Then you get 1 over y times dy over dx is basically just equal to f prime of x times 1 over f of x. So now just multiply it by y. So you get the dy over dx, which is the derivative desired, is just equal to y f prime of x over f of x, which is just equal to f prime of x. So this can actually be a really powerful way of solving it when you have like some really complicated exponent or whatever. So now let's, okay, I think I kind of went over a step. So first we have to know something really important. So let's say, well, we have life is not always going to be really ideal. So sometimes you get something like find the derivative of 2 of ln of x. Let's say 2 times ln of x plus 3. Right. So this one you cannot just, well, you cannot just find, you cannot multiply these two. The correct way to evaluate it is going to be using the chain rule, which states as follows. So we have, when we want to find d over dx, f of g of x is basically equals to f prime of x and g of x, no, f prime of g of x times g prime of x. So let me just interpret this really quick. So we're basically want to find the derivative of this composite function. So we're going to find the derivative of f of g of x by first leaving g of x and just find the derivative of f of x, and then just plug g of x inside and then multiply by the derivative of g of x. So if we take the example of find the derivative of 2 times ln of x plus 3, then you can either, well, you can either expand it, or you can just do the chain rule, right? So you can say it's basically just equals to two. You can just actually take it outside. So let's say we have something like, well, yeah, okay, I'm just going to make another learn. So we can just say 1 over ln of x plus 3 times 1 over x plus 3. So this is actually the derivative. So this is called the chain rule. So also we have a constant rule. So the constant rule is pretty simple. So constant rule is, let's say if we have a function called, you gotta find the derivative of 2g of x, of cg of x, cf of x. Which c is a constant. Then d over dx cf of x is basically just equal to c times d over dx times f of x. So basically what I did is you just move the constant outside of the derivative, which you can just check by considering the definition of the derivative. So this is actually pretty simple and also pretty intuitive. So let's proceed to the next one. So we have the product rule. So the product rule is, So product rule, let's say we have two functions. We want to find the derivative of f of x times g of x. Then, so let's say we want to find this derivative. Well, this letter might be too small, so I'm just going to make it bigger. So this one is not correct. To evaluate it as it's not correct to evaluate it as this. Well, this seems to be simple, but it's not the case of what's being correct. So instead, or f d over dx times of f of x times g of x is actually going to be equal to f of x times g of x, the derivative of f of x times g of x plus the derivative of g of x times f of x. So basically, you're taking the derivative and remain the other and plus the other way. So the order doesn't really matter in the product rule. But now let's go to the next one, which is the quotient rule. So let's say we have d over dx, the derivative with respect to x, of f of x over g of x. Then how are we going to solve it? Then this one is basically, this is kind of tricky to remember in the first place, but then you're start to used to it. So this is actually just simply equal to f of the derivative of f of x times g of x minus the derivative of g of x times f of x, an entire thing divided by g of x squared. So this one seems to be counterintuitive at first. However, you kind of get used to it after you do more practices. So now let's just look at a problem that's quite simple, but I kind of integrated with different topics. So find the derivative of 2x ln of x plus square root of x. Times dx, which cx, so this problem actually combines a lot of the topics that we just covered. So one of the more natural way and less bashy way is to split the functions. So let me just copy and paste since I'm kind of lazy to write it down again. This one can be written as 2x ln of x entire thing divided by dx plus square root of e to the x entire thing divided by cx. Which is just equal to 1 over c times d over dx times 2x ln of x div x plus square root x squared of e to the x divided by x. Consider this one to be kind of a little bit bashy, but now it's getting simpler. So we let f of x be equal to 2x ln of x. So we let a equals to 2x ln of x divided by x, which can be written as 2 ln of x. So we don't even need a function. So we don't even need a fraction. Then we write the derivative as 2 of x simply. Then if we b equals to the fraction of square root of e to the x power div x, which seems to be more bashy, but this one we can just use the quotient rule. So the quotient rule tells us that we're going to have the derivative of square root of e to the x, which is equal to 1 over 2 square root of e to the x times e to the x. Then minus entire thing divided by x squared. It's pretty kind of a little bit bashy. So now we can still simplify a little bit, which is equal to square root of e to the x power times x over 2 minus 1 entire thing divided by x squared. And this is basically our desired derivative for the part B. So we actually have, so we also know this additional rule, which is d over dxa plus db over dx, which is equal to d over dx of a plus b. The answer is desired is a prime plus b prime, which is equal to 2 over x plus and that is essentially our answer. So thank you for watching for this episode, and I'll catch you in the next video when we're going to talk about implicit differentiation and the derivative of trigonometric functions. Bye.